All right, so we're going to take it one step further this time. So we first have to find our slope. Then we need to find a line that is parallel and perpendicular. So one for the parallel, one for the perpendicular to this given line, but through the given point. Okay, so what do we do there? Well, okay, let's work through this. And so we have m is equal to what? 7/5. So for the parallel, we get m equals 7/5. Where'd my line go? And for perpendicular, we get m. Well, let's redo that there a little bit to make it nicer. We get m equals, now the reciprocal of that's 5/7, and the negative is a negative here. Okay, so now we know this. Now what we need to do is we need to use our point slope formula. And so we're going to use y minus y1 equals m times x minus x1. And then we can plug in our point and we can plug in one of our slopes for each of the times. So first time, y minus y1, well, y1 is 2 equals our slope, and let's do the parallel first. That's going to be 7/5 times x minus, and we have a 5. Okay, so we have to distribute y minus 2 equals 7/5 x minus, now the 5's cancel and we have a 7. Now we'll add 2 to both sides. We get y equals 7/5 x minus 5. And so that's for the parallel lines. Now, doing the excuse me, the perpendicular, we're say perpendicular, we're going to have y minus 2 equals -5/7 times x minus 5. So we're going through the same point, so we plug in the same values there. The only thing different this time is our slope is different. So now we distribute and we get y minus 2 equals -5/7x, then plus, now we have 25/7. So we can't do simple math like we did over here. We actually have to do this. Now we have to add 2 to both sides. And so we get y equals -5/7x plus, well, here we have to get that as 7/7. So we're going to have 25, and then that's going to be a 14, and it's all over 7. So that's going to be a 39/7. And so that's going to be our perpendicular line to our original line here. Okay, and so that's what we need to do when we look for parallel and perpendicular lines given a first line and a point. All right, what about this one? Well, this one we first have to find what our slope is, so we have to subtract 3x from both sides. So we get 7y equals -3x, divide by 7, and y equals a -3/7x. So our slope is equal to a -3/7. Now for a parallel line, m is going to be equal to that -3/7. For a perpendicular line, our slope is going to be equal to what? Oh, it's going to be the opposite of this, so it's going to be positive, and it's going to be 7/3. Okay. All right, so let's do parallel lines first. So we're going to have our equation again, y minus y1. Well, y1 is a -5 equals slope. Well, slope for parallel is -3/7 times x minus, and we have a -3. Okay. Well, what does that give us? Well, let's go ahead and say, okay, well, negative negative is positive, and negative negative is positive. And so now all we have to do is distribute. So we have y plus 5 equals a -3/7x. And then that's going to, oops, yeah, -3/7x. And then that's going to be a minus, and that's going to be a 9/7. Okay. Now we have to subtract 5 from both sides. So y equals a -3/7x, and then it's going to be minus. And now we have to multiply this one by 7/7. So I have a -9, and then here we have a -35. So that's going to give us a -44/7. That can't be reduced, and so that is our parallel line. Now what about our perpendicular line? Well, now we plug in the slope here and we use the same points. So it's going to be y minus a minus 5 equals 7 over 3 times x minus a minus 3. And again, we can go ahead and write those as plus. And so we get y plus 5 equals, now we're distributing here, so 7 over 3x. 3's cancel, we just have plus 7. Now we subtract 5. So we get y equals 7 over 3, and that's an x, and then 7 minus 5 is 2. And so that's our line perpendicular to our original one through that point. Okay. And so that's what a lot of this is. So it's a lot of practice. First, finding your slope of a parallel and then the slope of the perpendicular, and then using our point slope formula again and going through and then simplifying down until we have our slope intercept formula. All right, so let's pause there and we'll come back for more.